This is an introduction to long division and completing the square as methods of evaluating indefinite integrals. We usually use these algebraic techniques to evaluate indefinite integrals that can't be evaluated using U substitution. We usually use long division and completing the square in expressions where the fraction is too complex to set a specific U value and we can't use U substitution. So let's go over long division and then completing the square. In this question, we see it asks us to evaluate x squared minus 3x plus 2 the whole divided by x plus 1. Now, a technique to figure out when to use long division is to look at the degree of the numerator and the degree of the denominator. If the degree of the denominator is less than or equal to the degree of the numerator, you can use long division. The degree is the highest exponent of the expression. So for the denominator, the highest exponent is 1. X to the power of 1 or 1 to the power of 1 is the highest exponent. And in the numerator, the highest exponent is 2. And since the denominator's degree is less than the degree of the numerator, we can do long division. And just like in algebra, we do long division the same way. X plus 1 on this side, and put the numerator inside the box, and we work on the leftmost terms of each expression. So we're working with x and x squared for right now. So what we need to figure out is what value or variable times x gives us x squared. And that would be x. X times x equals x squared. Now, we need to multiply this value, what we got, with the leftmost term and then every subsequent term. In this case, there are only two terms, x and 1. So first we multiply x times x, x squared. And that's supposed to be right because we're finding out what variable or value will give us x squared. So we need to put the product below here. But a thing to note is you need to invert the sign. So if this is x squared, what we write down here will be negative x squared. And next term, x times 1 is positive x, but since you're adding it down below, we need to invert the sign and it becomes negative x. And there's nothing else, there are no more terms for us to multiply x by, so we can subtract. X squared minus x squared is 0. Minus 3 minus x is minus 4x. And you can bring the 2 down, just like in normal division. And now we can work with this. The leftmost term of this is negative 4x, and the leftmost term of this is x. What times x gives you negative 4x? Negative 4 times x gives you negative 4x. So now negative 4x, invert the sign, so it becomes positive 4x. And negative 4 times 1 is negative 4, but we need to invert the sign, so we get positive 4. Negative 4x plus 4x is 0, plus 2 plus 4 is 6, so that is 6. Now, once you get a constant over here, we know that nothing times a variable will give us a constant. So since we can't put anything here, which would multiply by x to give us a constant, which is 6, this is our remainder. So that means you're done. This is our answer. So this expression is equivalent to the indefinite integral of x minus 4, and we can't forget our remainder, which is 6. Right? But we can't write 6 by itself. We need to divide it by the denominator. So whenever you have a remainder, make sure to divide it by the denominator, what you're dividing by. So in this case, we're dividing by x plus 1. So this is our answer plus our remainder. And so this expression is equivalent to this expression. So now we can take the indefinite integral of this, and it's much easier because they're separate independent terms which we can use the power rule to evaluate. So we get x squared over 2 minus 4x using the power rule, and plus 6 over x plus 1. We can't use the power rule directly, but if you do a simple u substitution, u equals x plus 1 and du equals dx, we can replace x plus 1 with u. So that would be 6 over u, and dx becomes du because dx is equal to du, and that is equal to 6 times 1 over u, and 1 over u is identity. It's equal to the natural log of u. So this would be equal to 6 times natural log of u. Make sure to put the absolute value bars plus c. So now we can replace u with x plus 1 because that's u in this. So you can just add whatever we did here. The simple u substitution, we can add that here. Plus 6 natural log of x plus 1. And don't forget c. And that will be our answer for this question. So what we did was we found this expression to be too difficult to use a power rule or use the u substitution. So we did long division to simplify it, and then we used the power rule and a simple u substitution. For this question, we'll have to use long division as well as completing the square. So as you can see here, the degree of the denominator is 2 because that is the highest exponent, and the degree of the numerator is also 2, which means that the degrees are equal, and that means we can do long division. So write the the denominator here, numerator inside, and now what times x squared? We're working with the leftmost terms. What times x squared gives you x squared? And that's 1. 1 times x squared equals x squared. Now 1 times x squared is positive x squared. When you write it down here, when you invert the sign, so it becomes negative x squared. 1 times 4x is positive 4x, but we invert the sign, so it becomes negative 4x. 1 times 13 is positive 13, but we invert the sign and get a negative 13. Now, like I said before, we need to multiply this, whatever we got up here, by each term. So in the previous question, we only had 2 terms, but in this question, we have 3 terms as a denominator. So we multiply by each term and invert the sign when we write it down here. So x squared minus x squared equals 0. Positive 4x minus 4x equals 0. And negative 13 by itself is negative 13. Now what we have here is a constant, and like I said before, if there's a constant, nothing times a variable will give you a constant. So this is our remainder and this is our answer. So together we have 1 minus 13. Remember to divide it by the denominator. It's not 1 minus 13, it's 1 minus 13 divided by x squared plus 4x plus 13. So this expression is equivalent to this expression. All we did was divide it. It's the same principle. When somebody asks you 6 divided by 2, that's also equal to 3. All we did was divide it. From here we can do the power rule for 1, but for this we have to do something different. So we can separate these using the identity. So we can say the integral of 1 minus the integral of 13 over x squared plus 4x plus 13 dx It's equivalent to this, right? So if you integrate 1 with the power rule, that just gives us x plus c. And for this, we need to do something called u substitution. We can't use, actually, we can't use u substitution. We're going to use completing the square. The reason we can't use u substitution is because we can't make u a constant. That's not allowed. We can't make u a constant. That's not achieving anything. And if you try to make u the denominator, the expression we're trying to make u cannot have a degree higher than 1. And in this case, the degree is 2 because the highest exponent is 2. So we can't use u substitution. In this case, we can do completing the square. So another simple algebraic technique will work exclusively with the denominator, x squared plus 4x plus 13. What you need to do is remember the quadratic formula, ax squared plus bx plus c. Now this is ax squared plus bx, and the moment you write ax squared plus bx, put brackets around them and leave a space towards the right of bx, and then write plus c outside the brackets. Now what we're doing here is we're completing the square. We are taking the constant connected with bx, so the value of b is 4 in this case, and what we'll do is we'll half that. So we half b value, so 4 divided by 2 is 2, and then we square it. 2 squared is 4, and then we add that value here. Or you don't, yeah, you will add that value here. And so the formula to remember is half the b value and then square that value, and you write that value here inside the brackets. And we can't just simply add something. We also need to, if we add something, subtract something, so that this expression is equivalent to this expression. Because if you add something and subtract something, it's basically 0. It is 0. So we subtract 4 here. Now what we're doing is x squared plus 4x plus 4 can also be written as x plus 2 the whole square. Right? If we use the identity, you get x plus 2 the whole square. And 13 minus 4 is 9. So what we have now is this as the denominator. This is equivalent to this. All we did was complete the square. So we can go erase this to get more space, and we can replace this with x plus 2 squared plus 9. So x plus 2 the whole square plus 9 dx. Right? And now, what's the point of this? The point is we can use a trig identity. If there's a square in the denominator that looks like this, we can remember the trig identity 1 over 1 plus u squared, which is the integral of tangent inverse. Actually, yeah. So we can say x plus 2 squared plus 9. And now we can make a simple u substitution. What we want to do is make u 9u squared. And you'll see where I'm going with this. 9u squared equals x plus 2 squared. Okay? And so if you write this like this, then we can replace x plus 2 the whole square with 9u squared. And let's see what we get when we do this. So this is part of our answer. right? And we're evaluating this part for right now. So what we get is 13 9u squared plus 9. And since we removed x and put in values of u, we need to replace dx with du. So we just say u squared equals x plus 2 square, the whole square, divided by 9. And that means u is equal to x plus 2 over 3. Right? And if x plus 2 over 3 is u, then du is equal to the derivative of this, which is x over 3 plus 2 over 3. 2 over 3 is a constant, so that goes to 0. X over 3 is simply du will be equal to the derivative of x over 3 dx. No. It will actually be it'll just be 1 over 3, right? So 1 over 3 dx. So that would mean dx equals 3 du, right? X over 3 is, x turns to 1, and 1 over 3 is 1 over 3. You're just taking the derivative of x over 3. So that's 1 over 3 dx, and dx is equal to 3 du. Okay? So we can replace dx with 3 du, right? Let me just make space. du. Now we can take 13 and 3 outside to make this simpler. So 13 times 3, which is 39. 39. We can take constant out. That's a law of integrals. So, and then we can do 9u squared plus 9, and then du. Now what we can do here is we can take the 9 outside as well, right? So we can take 9 outside, and then 9 times u squared plus 1. 39 divided by 9, because 9, it's 1 divided by 9, not simply 9. It's 1 divided by 9, and then integral of 1 over u squared plus 1 du. And as I said previously, 1 over u squared plus 1, or 1 over 1 plus u squared, is a trig identity tangent inverse of u. So we get 39 over 9 tangent inverse of u plus c. Now we can't leave our answer like this and make space, because we have not found our u value. So up here I'll write our u value. Like I said previously, 9u squared equals x plus 2 squared. And so that means u will equal to x plus 2 over 3, right? So we can just replace u with x plus 2 over 3. So I'll just write this up here. And don't forget about x plus c, because that's part of our answer as well as the negative sign. So you can write x minus 39 over 9 tangent inverse of x plus 2 over 3 plus c. Plus c and plus c is just plus c. And yeah, so that is our answer for this question. So we started by doing long division. We got 1 minus 13 over x squared plus 4x was 13, and so we could separate those two. We could take the integral of 1 and then the integral of negative 13 over x squared plus 4x plus 13. We took the integral of this using the power rule because it's really easy. That's x plus c. And for this, we had to do completing the square, and we got x plus 2 the whole square plus 9 as equivalent to x squared plus 4x plus 13. And so we replaced it, and we did a simple u substitution. We took 9u squared equals x plus 2 the whole square. So you could replace x plus 2 the whole square with 9u squared. And the reason we took 9u squared as this value is just so that we can take a 9 outside. And if we take a 9 outside, we get 9 times u squared plus 1. And 1 over u squared plus 1 is an identity, tangent inverse of u. So that is how we arrived at our answer. Looking at this question, we can see the degree of the denominator is 1, the highest exponent is 1, and the highest exponent of the numerator is 3, right? So we can do long division. X minus 3 divided by x cubed minus 3x squared plus 5. Now, working with the leftmost terms, we can see what times x gives us x cubed. X squared times x gives us x cubed. And now we multiply. X squared times x is positive x squared. Invert the sign, negative x squared. X squared times negative 3, negative x squared. Invert the sign, positive 3x squared. And this cancels out to be 0, 0. And we get positive 5 as our remainder. So now what we can do is write this x squared plus our remainder, which is divided by our denominator, and this is equivalent to this. And so you can take the indefinite integral of x squared minus 5 over x minus 3, and we can use the power rule. So evaluating this, we get term by term, we get x cubed over 3 minus, and hopefully by now you understand that if you do a u substitution with the denominator being with the degree of 1 as the denominator and a constant on top, you get minus 5 natural log of the denominator, which is x minus 3. And the reason behind this, plus c, the reason behind this is if you take u as x minus 3, then du equals dx, right? Taking the derivative on both sides. And if you do that, you get, we can replace x minus 3 with u, so you get negative 5 over u du, because dx equals du. And negative 5, that's equal to negative 5 times 1 over u. And 1 over u is a trigonometrical, it's a identity, not trigonometrical identity. 1 over u is natural log of u. And so u is x minus 3, which is our denominator. So without doing u substitution, you can simply take the numerator and multiply it by the natural log of the denominator. And this is only when the degree of the denominator is 1 and the numerator is a constant and there are only 2 terms in the denominator. Yeah. And so this will be an answer for this question. We did simple long division, we rewrote our expression, and we did power rule and then a simple u substitution.